Oh, this pencil's
All right, okay, so, real quick, practice guide in your hands. You will need a calculator for some of these. It would be a very smart idea to have one, and I'll ask for certain things. Remember, on test day, I will not tell you how to type stuff in your calculator. I will not show you how to do that. I will have select formulas on the board, plus you have your property sheet you can be using. But if you need a calculator, I'll explain what you need to do. Now, if you're borrowing one of mine, that's fine, but I will not show you how to use one if you bring in your own and you don't know how to use it that day.
Wow.
So that's a type of question you can ask today or Monday, but not test day. Question?
Is the formula for converting from degrees to radians maybe on the board?
Yeah, it'll be on the board somewhere. So, alright. Okay. Alright, so first, we're going to convert this to a radian. So to do that, you multiply by pi over 180. Okay, hey, just to remind you, this formula, like Justin just asked, it will be on the board, but you have to know how to use it. I'll probably just have the conversion formula, and I'll just put pi over 180 on it. I won't even say what it's for. Okay, so when you do this, this turns out to be 300 pi over 180, and yes, you do have to simplify that fraction correctly, and I do not want a decimal. It needs to be an exact multiple of pi. So that means you can chop up the zeros. You can divide both numbers by probably 6. Yeah, you're probably right. So that's what, 5 pi over 3, and that'd be the simplest form of that problem. Okay, you can do that for the next one. Even if it's negative, just leave the negative sign on it. It's totally fine. Make sense? We're good. Okay, moving on. Let's move on to number 3. Again, this one you'll need to do on your own.
Oh.
Okay? Alright, I always try to do at least one for you, try one by yourself, that type of thing. Questions on the first one though?
No.
Okay, it needs to be simplified, leave it a fraction. If it's negative, just leave the negative sign there. Moving on. Number 3 and 4, these are convert these to radians. It's basically this, or convert the radians to degrees. Apologies. So on this one, you need to multiply by 180 over pi. So we'll multiply by 180 over pi. That's the conversion to convert it back to degrees. Now why I know that? The pi's will cancel out, and then what I'm left with is 180 over 9, which I believe if you simplify is 20 degrees. Now, here's my quick little thing I want to remind you of. If I start with one of these as a weird decimal, so let's say it's like, let's say problem number 4 here, let's say this is number 4, and it says like 2.31, and that's supposed to be radians, it's not even degrees, so I don't have a little degree symbol on it. Like 2.31, you still multiply by 180, you still divide by pi, your answer will be a decimal though. It is totally fine that you can get a decimal if you're going to radians on that one. If it's a nice clean number or a nice fraction, you can leave it. But if it starts with a decimal and you're converting it, it's going to be a decimal in the end. It's just going to be ugly. So just take it times 180, divide by 3.14, go 3 or 4 decimal places, then hit enter, and that's your number. Okay, I'll probably have both on my work. I just want to warn you if there is a decimal there, because the book did have some of those, where they just give you a weird decimal in the beginning. Questions on how to do that?
Are you going to actually put one of those weird decimals on the test?
I picked one at random, and I picked these a while ago. I think I just picked normal ones. I didn't pick any weird decimal ones because I just wanted to make sure that it was easy to calculate in a couple seconds. As you can tell from like this, they're very, very straightforward and pretty easy.
Yeah.
Okay, questions? All right, so there's your 1 through 4. Those should be easy points for you as long as you know the conversion tool. Let's move on. Okay, 5 and 6. Now, these ask for coterminal. This coterminal means you add or subtract 360. I want 2 of them. So if you see this, I want 2 coterminal. 2. So you have to add 360, subtract 360, or add 360 twice, or subtract 360 twice. Notice I didn't put a stipulation where I need a positive and negative. I did that in the homework. I don't have the thing here. So you can go any direction. I'll probably have 4 different answers written down, but I just want you to add 360 or subtract 360, any direction you want to go, but you need 2 answers. So I'll do the first one. Let's say for this first one here, the first answer I'm going to do is I'll add 360 to it. So if I add 360 to this, that's a 775. Okay. So if I add 360 to it, and if I subtract 360 from it, let's see, that's what, 45 degrees, something like that?
55.
55?
55.
Okay, I can't subtract that. All right, that's terrible. All right, any questions with the two answers I should be getting? Now again, you could have added 360 twice, you could have subtracted 360. Now what these answers are, these things. These are my two answers. Okay? What these are the same angle if you were to draw them. If you were to draw a 55-degree angle, and you were to draw a 775-degree angle or a 415-degree angle, they all land right on top of each other. It's the same looking type of angle. It's in the first quadrant. It's, kind of midway through it. It's not, it's not obtuse or anything like that. Even though I know that some of these numbers are big, they just spun full circles. You landed in the first quadrant anyway. Now, this one on your own, this one, same thing. It's negative. You can add 360, subtract 360, whatever the answers are. Just make sure that if your answers are negative, keep the negative sign on it. Because I know some person's going to subtract 360 and they're going to forget the negative sign, and you count that wrong if you forget negative signs. I'm kind of picky about that. So just kind of keep that in mind. If it's negative, keep it negative. Okay, questions? Does that make sense how to do those? I think the first page, you should get some serious easy points going. Like, it shouldn't be super difficult. I always like to try to put some problems on the test that you can easily calculate, that it doesn't take a lot of mental effort.
Page 2 does not seem the same way.
What?
Page 2 does not seem
Okay,
the same way.
page 2 really jumps into it now.
It does.
Okay, it does. It jumps into it hard. All right, so
Jumping into it. I don't know how to do that.
What page you?
I don't know. Yeah, I did.
yeah.
My brain.
All right, here we go.
This is a real brain.
Okay. All right, the formula. The formula for number 7 and 8 is on the actual test. It's the same. I just have it in that same spot. That's the formula we have to use. The trick is you got to have a certain angle, which is right here. You got to have a certain type of angle, and you have to have the radius. And then you have to do a quick calculation. Now this angle, what type of angle does this have to be?
Theta.
Well, theta.
Theta angle.
Right? Say it.
Beta.
Yo, somebody said it. What
Reflex.
form? Is it radian or degree?
Radian.
Oh.
Radian.
Oh,
I thought I heard somebody say it.
Reflex.
All right, no. It has to be in
What
radians.
type of angle does it have to be? Theta.
No. If your angle is not in radians, you'll get an incorrect answer. So I'll do the first one for you. The second one's pretty much the same way. The second one's actually easier. All right, so on this one, we're going from noon to 4. So if we're going from, and I'm going to draw a mock picture. You don't need to draw this. But if I'm going from 12 o'clock to 4 o'clock, that's 1/3 of a full rotation. Now, why I know that? We went 4 hours out of 12, so this is 1/3 of a revolution. Okay, now, how this works. 1/3 of a revolution, that's 1/3 of 360 degrees, which is 120 degrees. So that's my angle from noon to 4. That's the angle that my clock hand is taking. It's taking a 120-degree angle. You can kind of see it from my mock picture here. Now, again, how I did that, I took the 4 o'clock divided by 12 because there's 12 hours in a clock. So that's how I got the 1/3 of revolution. I always take it times 360 and then I convert that back. To convert this 120 degrees back to radians, you take it times pi divided by 180. That's how I convert it back to radians. Because that's what we did on the first page, right?
Yeah.
So we divide both by 10, so we get 12 pi over 18. Divide both by 6, I get 2 pi over 3. Now there is a shortcut for doing that, but I don't want to confuse anyone, so I'm just going to leave it like that. That's my radian angle. Now, to find my final answer, how far did the tip of the hand actually move? You take the radius, which is my 6 inches on this problem. They say that's the radius of my clock hand. You take it times your radians, which is 2 pi over 3, and that should give you your arc length. This is the arc length, how far the hand is traveling along a circular path. That's what you're going to do on this one with the Ferris wheel. You have a 25-foot radius. You have a certain angle that you're making. You're doing 2 full revolutions, so that you're spinning a lot. So that's a big angle. And you're going to convert. And I have a typo here.
What's the,
The typo should be wheel. Make a correction on that one. I forget to change that every year. I had water there. It should have been wheel. It must have auto-corrected. So make a correction. That is a typo in there.
what is the label for number 7? Would it be inches?
Yeah, it'd be inches. So, okay, hey. Shh. Shh. All right. So to type this in to get the exact answer, you take 6 times the top divided by 3. You should get 4 pi inches. That's the exact answer if you actually take 6 times 2 divided by 3 with a pi on it. And then when you actually multiply this turns out to be like 12 point something, doesn't it?
12.56.
All right, inches. That's the exact answer. Again, I wanted my answer in terms of pi and 2 decimal places.
Oh, 2 decimal.
2 decimal places.
So
Okay, now, whatever your angle is, so like on your next problem, it says you're doing 2 revolutions, that's 2 360s. And then you convert it back to radians, take it times your radius, and you're good to go. Okay? So just make sure of it, and I know it says linear speed of the water, but it means of the wheel, sorry. I don't know why, but I always fix it, and then every year I must pick the other practice test. I always pick the other practice test I haven't fixed yet, so, because I bounce back and forth every other year. All right. I gotta fix it. I always forget that. All right.
Fix it right after this.
I should. Questions on number 8. Okay. Again, you have to get it to radians. Take it times your radius. You're good to go. The types of problems I can put here, obviously a clock, a Ferris wheel. I can put the globe problem where you have, a radius of the Earth and you have a certain angle that you're traveling through on the Earth, and you can find the distance that you covered on the Earth. Those are types of problems I could put. I would personally expect something like this. Like 2 of these. These are probably the more common sense ones.
314.616.
Yeah, that's what I got. 4 pi times
Okay, hey, we good?
Yeah.
100 pi.
There's a lot of pies, Justin. JP, you should be a baker.
All right, here we go. We're going on to number 9. All right, now this is one that we covered in class one day, where we talked about when we talked about unit circles. If you were gone that day, you might have missed some crucial notes. We talked about unit circles. Unit circle is when you have a length of 1, okay, and you spin around in a big circle. And so these are answers for like, if you had 0
Cosine,
degrees,
sine.
that would be like cosine and sine. Well, when they put you at a certain spot on a unit circle, this is the cosine answer, this is the sine answer. And what they want you to do is to draw the triangle for that unit circle, and then find all the trig function values. All the values of the trig function.
Everyone?
Every single one. So, here's the thing.
So we get 4 days for this test?
I already have cosine, I already have sine's answer, because they gave me that if it's a unit circle, which it is. It is actually a unit circle. So the cosine's answer is negative 15 over 17, and sine's answer is 8 over 17. That's the actual numbers, that's it. That's the numbers that are involved here. I can find its reciprocals real easy, because secant is the reciprocal of cosine, so I can flip that answer over, and cosecant is the reciprocal of sine. So all I have to do is flip these fractions over. And it made sense, I'm in the second quadrant, so,
Is this
cosine
gonna
was
be
negative.
negative?
What?
Is this still gonna be negative?
Yeah, cosine is negative. If you flip it over, it's still negative, yep. Sine's answer is positive because you're in the second quadrant, so it all makes sense. The only one that you really have to figure out is like tangent, right? A lot of people are like, well, Ward, how do you find tangent? Tangent's not given to you. You have the triangle though. In fact, if you know what cosine means, you actually have a triangle in that second quadrant. Okay, so I'm going to put theta here.
Yes.
What does cosine actually mean as a fraction?
Cosine means the opposite over hypotenuse.
Nope.
Or adjacent.
Adjacent. So this is
My
the
bad.
adjacent
So good though.
over hypotenuse. So this is like the cheating way to figure out tangent. You can do the Pythagorean theorem, which we don't need to because we already have the sine answer. Sine is opposite over hypotenuse, so I have all the walls I need. Where I have the opposite wall, I have the adjacent wall, I have the hypotenuse because they're both 17s on the bottom. And now that I have that, I can rattle off what tangent is. What's tangent according to this triangle? 8 over negative 15. And again, how I did that so fast is because I know I'm in the second quadrant and I'm drawing a triangle there. These are my walls for that triangle, for sine and cosine. Cosine and sine,
Based
sorry.
off the angle closest to the 0.
Closest to 0, yep. And that's how I can set up these walls, and this is my cheating way to figure out what tangent is. Because cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, so I have all the walls of my triangle. I don't even need to do Pythagorean theorem, because that's my answers. And then I can rattle off tangent from that. It's opposite over adjacent. And now you can flip it over and do the cotangent and all those. Okay, so number 9 is not hard, but you got to understand that little trick for how you set up the triangle, and you can do it all. Okay, questions?
No.
Perfect. All right, let's move on. Okay, the last ones. Hopefully that makes sense for how I can cheat that. We talked about that one day in class. It's just we didn't do a lot of problems. So I want to make sure if you were paying attention. All
I'd
right.
like to hint here on this one. That's very
Yeah. All right. And I'll probably have a hint there test day. All right.
good. I probably couldn't.
Okay. Cofunction is that certain trig functions have a certain pair, not the reciprocal, the cofunction. So the cofunctions, if you don't know, sine and cosine are paired together. Cosine. Tangent, cotangent, even though they're reciprocals, they are paired together as a cofunction. And then secant and cosecant are paired together. And what that means is that all I want, I know this is going to seem a little silly, that they want to know what thing could you type in your calculator that would give you the exact same answer as the sine of 19. So what you do, and again, if it's in radians, convert it back to degrees. That's what I would do.
You gonna do that to us?
But I did one here. All right. So now here's the idea. If I give you the sine of 19, here's how you figure out the cofunction of sine is cosine, and then the trick is you just use the complementary angle, 90 minus the angle that they used. 90 minus that. It is always 90 minus whatever that angle is that they gave you. So whatever this turns out to be, this is cosine. What is that number? 71 degrees. That's your answer. That's all I want. And then you move on to the next one. It wants the cofunction, and it wants to know that angle that you have to put in there that would give you the same number. If you type this in your calculator,
It's the
sine of
same
19,
thing,
it's the
0.325.
same answer as the cosine of 71. It's the same answer. That's how you can double check that you do it right. But they don't want to know what the decimal is. They don't want to know the fractions. They don't want to know anything like that. They just want to know what is the cofunction that will give you the same value.
What?
Now we gotta find tangent.
And then, so you're absolutely right. So the next one, you're going to find tangent. You'll have to convert this to degrees, and then you can do all my math that I just did there, 90 minus whatever that angle is. Okay?
Would you do 90 plus though, since you're going back?
No.
That's in
So
radian.
No.
So it's always the complement.
No.
All right. Moving on. The cofunctions, I'll probably have them listed somewhere on the board test day. They'll probably be maybe somewhere in the middle of the board. All right. That should be the last ones today. I don't think I have any other problems on the first page anyway. Yeah. All right. Monday. All right, Monday.
90 minus that, so it's
Hey.
1.5.
On Monday, we will continue on. We'll do the second, or I guess the second page, technically the third, if you go front, back, front. Right, we're going to start here. We'll show you how to type these in your calculator. That's a day that whatever calculator you have will be the one that you want to use test day. We'll talk about the story problems. We'll talk about, how to find all the remaining trig functions. This one's a lot like that problem number 9. We'll be using reference angles. These last ones are the ones where you draw waves. And you have to draw those. Okay. Hey, just a quick reminder, if you're doing these on your own, because I know some people have already tried, this +2 is not in the parenthesis. If it was, they would have to put a parenthesis down here. I'm not going to do that. We didn't have any in the homework. I would never assign that for the test. There's just the 2 pi is the only thing in the parenthesis with the x. The +2 is it's shifting it up and down too. Okay, you got to figure that out. Okay, so be careful on that. This probably should not need a calculator for it. These you should need to unless you don't know how to take like 490 minus 360.
That's just a gentle hint.
All right.
Do not use it.
Use a calculator, Lucas.
Okay. Questions.
Is this the longest test we've ever had?
on.
Yes.
Can we take a nap?
No, one of our first tests had like 20 some questions.
Is this the longest test we'll have?
Probably, it's close to the longest one we've had.
And the hardest
Oh, are we
ones.
gonna
Okay,
have
no,
this
this is
on?
definitely not the hardest. You have not seen difficult yet.
Why does it a bit?
Jace,